In this video, what we're going to explore are problems involving angles in a rectangle and angles in a parallelogram. So rectangle and parallelogram are some types of quadrilaterals, and quadrilaterals are any four-sided figures. But before that, let us first get familiarized with the properties of rectangles and properties of parallelograms. So the first one are the properties of a rectangle. We have here in the figure we have a rectangle ABCD. In terms of parallel side, in a rectangle there are two pairs of parallel sides. In this case, the parallel sides are the first pair is the AB and the CD. They are parallel, and the second pair is the AD and BC. In terms of equal sides, in a rectangle, opposite sides are equal in length. So in this case, we have AB is equal to CD and AD is equal to BC. So the sides marked in purple are equal, and the sides marked in red are also equal. Then in terms of interior angles, a rectangle has all four angles which are right angles. So meaning this gives us this angle here is 90 degrees, this angle here is 90 degrees, this angle here is 90 degrees, and this angle here is 90 degrees. In terms of diagonals, so by definition when we say diagonals, it's simply a line that connects the opposite vertices of a polygon. So it's a line that connects the opposite vertices of a polygon. So in this case, in this rectangle, the diagonal is BD and AC because they connect the opposite sides, the opposite vertices rather. So in a rectangle, the ones marked in red, the diagonals are equal in length. Then diagonals also bisect each other. When you say the word bisect, meaning cut an object into two equal parts. So meaning when BD bisect AC, AC now will be cut into two. So that gives us here a simple notation, which gives us AE becomes now equal to CE, because it is being bisected by the AC is being bisected, cut into half by the diagonal BD. Vice versa, the AC as a diagonal, it also bisects the other diagonal, which is BD. That gives us a conclusion that BE is also equal to DE. So they bisect, the diagonals bisect each other. So the word bisect means cut, an act of cutting an object into two equal parts. So when we cut an object into three equal parts, we call it trisect. So those are the properties of a rectangle. So what is the importance of these properties is that when we are familiarized with the properties of a rectangle, it makes the solving of the unknowns or the problems related to a rectangle easy, because we have some guides about the properties. This becomes our basis on how to set up equations. The next quadrilateral under consideration is parallelogram. So the same with rectangle, parallelogram has two pairs of parallel sides, the CD and AB being parallel, and the other pair is the BC and AD. By notation in mathematics and in geometry particular, to mean parallelism, take note of the arrows, meaning they are parallel. Notice that CD and AB has two arrows there, meaning they are parallel. In terms of opposite sides, equal sides, the opposite sides of a parallelogram are also equal. The AB and the CD and the BC and the AD. So the same with rectangle. And in terms of interior angles, when you say interior, opposite angles rather, in terms of interior angles, the opposite angles of a parallelogram are also equal. So when we say opposite angles, this is very important because it's a property pertaining opposite angles, because what our main goal for this lesson is actually solving unknown angles in a rectangle and in a parallelogram. So suppose we have a parallelogram here. These are the opposite angles. So this is A, this is B. Therefore, since they are opposite, we say A equals B. These are also opposite angles. So they are opposite, so you say X equals Y. Because that's the property of a parallelogram. Opposite angles are equal. Then again, in terms of diagonals, the same so with rectangle, the diagonals bisect each other, meaning they cut each other into half, into two equal parts. So these are the properties of rectangle and parallelogram. The other quadrilaterals will be tackled, will be discussed later on. So it is very important that we keep in mind these properties, because again, this becomes our basis in setting up equations, and in a problem, when you can correctly set up an equation, that's it, you can solve the equation. Okay. So it's like saying, how do we turn the problem into an equation, and our what we call this, our medium of turning that problem into an equation are actually the properties of the figure involved in the problem. Okay, so for example, problem talks about parallelogram. Then how can we set up an equation about that problem? Is we're going back to the properties of parallelogram and some other useful concepts that's incorporated in that parallelogram problem. So before we jump into the angles involving rectangles and parallelograms, let us first have a quick look about some important concepts that we already discussed before. Because these important concepts are important, again, they may be incorporated in the problems about rectangle and parallelogram. So again, these concepts were already discussed before when we started our geometry journey. So number one is, if we have angles on a line, they all add up. Angles on a straight line, they all add up to 180 degrees. So here we have a straight line, and there are angles within that straight line, adjacent angles. In particular, we have angle A, angle B, and angle C. So these angles, when you add all this is 180 degrees. Next is vertical angles. When two straight lines intersect, they form vertical angles, and those vertical angles are equal. So in this illustration, the vertical angles are A and B. These are also vertical angles. Let's mark that red. They are also equal. Okay. The next is number 3. We have angles at a point add up to 360 degrees. The point at a point, meaning all of these angles are sharing common point. So as you can see, this point. Okay, so it's like a rotating angle. It's like a rotating angle. So it's one complete circle. So that's 360. So when you add all A plus B plus C, that's 360 degrees. So these are I think this is the very first lesson of our in our geometry journey. So do not forget this one, because they will just pop up somewhere else in any geometry problem. Next is we have parallel lines and a transversal. So again, parallel lines, they are those with the same direction and the same direction with no intersection. Okay, but in later on concept about parallel lines, you will learn that there are more about parallel lines, such as slope, when you get to your grade 8 math. So here we have two parallel lines, the line 1 and line 2. Then we have the purple line, that's what we call transversal. And we know, as we discussed before, transversal is a line that cuts other system of lines. Okay. So the purple line is a transversal. Upon cutting the parallel lines, line 1 and line 2, there will be angles will be formed, and these angles have actually relationship, and we discussed before those angle relationships. Okay, so the premise is that the basic premise of this situation is that if line 1 and line 2 are parallel, then corresponding number 1 corresponding angles are equal. So when we say corresponding angles, these are the angle A equals to angle E, then angle B, angle F, then angle D and angle H, then angle C and angle G. So you have to try to familiarize their locations, their relative locations in this situation, in this figure. That's number 1. Number 2, if line 1 and line 2 are parallel, then alternate interior angles are also equal. So alternate, because when you say alternate in this perspective, the word alternate means the other angle is on the right side of the transversal, the other angle is on the left side of transversal. So as you can see, line C and line E, okay, so let us erase first some of this. Okay, line C and line E are alternate. They are inside the parallel lines, so that makes them interior. Okay, so alternate is because they are on the left and on the right side respectively of the transversal, which is the purple line. Interior, it's because they are between the parallel lines. Okay, so B and H are also interior, and they are alternate interior angles, then they are also equal. Then number 3, alternate exterior angles are equal. So it's the same with alternate interior, it's just that it's outside the parallel line. So that, for example, in this figure we have angle D and angle F, then angle A and angle G. So those are the 3. Then we have the last one is the if line 1 and line 2, then number 4, you have consecutive interior angles. Consecutive meaning they are on the same side of the parallel lines. They are on the same side of the transversal, and they are inside, interior. So when I say supplementary, that's actually 180 degrees. So as you can see here, we have the consecutive interior angles are B and E. So as you notice, they are on the same side of the transversal, and they are inside the parallel lines. The same so with C and H. They are also consecutive interior angles. So when we add them, they are supplementary, meaning their sum is 180 degrees. So that's the next important concept in geometry that will just pop up anywhere in problems, geometry problems. Okay, next we have angle sum of a triangle. This is very famous for us. When we add all the interior angles in a triangle, they all add up to 180 degrees. Next we have exterior angle, meaning outside the triangle. So here the exterior angle is X, and as we learned before, this exterior angle is just equal to the sum of the opposite interior angles of a triangle. So that's the A and B. So we say angle X is just equals to the sum of angle A and angle B. So those are the important concepts, really the properties, these angles, parallel lines and transversal, angle sum of a triangle, and exterior angle of a triangle. So try to, when there is a math problem or a geometry problem later on, try to spot these concepts there in that problem and see if you can use them. Okay. So that is why the mastery of these concepts is very, very necessary. So let's jump into our problem number 1. So we have here, so this is a rectangle, so let's define that this figure is a rectangle. Okay, so we have x. What is the value of x? So x is just simply 55 because they are alternate interior angles. Okay, so you can see the properties of one of the property of a rectangle is that their opposite sides are parallel, meaning this side here, let's draw that one, this side here is parallel to this side. This line here acts as a transversal. So notice when there are parallel and there is a transversal, these are the interior angles. So yeah, so x and 55 are alternate interior angles. So x is 55 degrees, or simply x is just 55. That's how easy. Next we have y degrees. What's the value of y? As you notice, we can clearly see here that the y degrees and the 88 and the 55 are all on a straight line. So we can use the 88 and the 55 to find the value of y. So that gives us set up the equation. That is the important thing. You determine the unknown first, which is the unknown, then try to relate it with the other known angles, then set up an equation based on what you have already learned. Okay, so we have already learned that when angles are on a straight line, they add up to 180. So yeah, y can be is related to 88 and is related to 55 by angles on a straight line. So we say y degrees plus 88 degrees plus 55 degrees, they all add up to 180 degrees because they are angles sum of a triangle. Okay, so subtracting, when we add 55, this is 163. Subtracting 163 from 180, therefore we have, that gives us around like 17. No, it's not 163 rather. So let me correct it. So 50 and 80, that gives us 130, and plus 13 we have 143. Sorry, that's 143 degrees equals 180. So subtracting 143 from 180, we have 37. So y is simply 37. So that's it. That's our first concept. So what concept before we use? We use the concept that alternate interior angles are equal. Now, before we jump into the concept of, they are alternate interior angles, we use the concept of parallelism. Okay, and when do we know? Why do we know that we can use the alternate interior angles? Because we know that the property of a rectangle, their opposite sides are equal. So again, in this problem alone, we already combined three concepts. Okay, number one concept is that the opposite sides of a rectangle are parallel. Okay, number two, because of that parallelism, we were able to use the concept of parallel lines and a transversal, which is, it leads us to the alternate interior angles. Then number three concept we use is actually the angles on a straight line to solve for y. So as you can see, in solving complex geometry problem, these are just combination of the small concepts. So next is also a rectangle problem. So we have here unknowns which are a and b. So let's solve for a first and b. So notice that a is an exterior angle. Notice that? So this is 90 degrees. Look at this. This is 90 degrees. How do we know that it's 90 degrees? It's because it's a rectangle. Why is it rectangle and 90 degrees? One property of rectangle is that all interior angles are all right angles. Meaning, yeah, this is 90 degrees because that's again we use the property of rectangle being the interior angles being 90 degrees. So now this is 50 degrees, and we know exterior angle of a triangle. So it's like A is the exterior angle of this triangle here. So we know that the exterior angle of a triangle is just the sum of its opposite interior angles. So A is simply 140. Done. So it looks complicated at first, but knowing some small concepts, combine them together, then yeah, we can set up our equation and solve for the unknown. Next is we have the B. So how can we relate the B into that? So here, notice that 5B and 100, we can treat this as a triangle and add all these angles to 180 degrees. Except if we know other given that we can relate to 5B. But I think in this problem, we can only relate 5B to 100. And we know that this angle, that total of this angle, so let me mark that this is 90 because one property of a rectangle is that the interior angle is 90, and we have already 50. This gives us this angle is 40 degrees because 40 plus 50 is 90 degrees. That is a right angle now. Okay, so meaning we can use now the 40, the 100, and the 5B as interior angle of the blue triangles. So from that, we can set up our equation. We have 5B plus 40 degrees plus 100 degrees equals 180 degrees. Why is this? So this equation is based on angle sum of a triangle. Okay. So from that, this is 140, and taking away 140 from 180 degrees, so we have 40 degrees. That's equals to 5B degrees. So divided by 5 divided by 5, B is actually 8. So yeah, you're done. Okay. So the good thing about geometry is that it may allow us to have really multiple methods and solutions. Okay, so we have next is a parallelogram problem. Okay, so this figure is a parallelogram. So again, we go back to let's solve for x first. The givens here are 110 degrees, 7x degrees, and 2y degrees. We're going to solve for x first. Okay, so in this scenario, we can use 7x and 110 degrees. I think this one is that 110 degrees and 7x, they are consecutive interior angles. Again, we know that these opposite sides of a parallelogram are parallel. Okay? And this side acts now as a transversal. So let's go back to the idea, to that illustration, this one. Okay? The B and the E. So it's just like that. Okay? So going back there, meaning if you're going to add that, they are supplementary. That's 7x and 10. So 110, 7x degrees plus 110 degrees. They are supplementary. So subtracting 110 from both sides, you have 7x degrees, 70 degrees. Divide by 7, x is simply 10. Done. So again, master, not just familiarize, master the prerequisite concepts. And prerequisite concepts that are, which are supposed to be applied here. Okay, the one we reviewed a while ago. Notice that in a parallelogram, so let's go back to that. In a parallelogram, the angles are, look at this, opposite angles are equal. So with this illustration here, so there, look at there, let's try to look at there. Okay, so again, let's reason out first here. It is important that we state our reason for setting up the equation. Why did we set up 7x degrees plus 110 degrees equals 180 degrees? Is because they are consecutive interior angles. Consecutive interior angles, and they are supplementary. Okay, now we have the 110 and 2y, they are equal because they are opposite angles. So 2y degrees is 110 degrees, they are opposite angles are equal. Of course, this is in a parallelogram. Okay, opposite angles are equal, so divide by 2, therefore y is just simply 55. So that's how easy. Next, okay, here becomes now a little bit complicated. Okay, so we're going to solve for 5x. Okay, we're going to solve for 5x. Oh no, for x rather. I'll provide two solutions for x, so that, yeah, in geometry we can have, in mathematics in general, we can have multiple ways of solving a problem. So notice that this must be also 40 degrees because it's alternate interior angles. They are alternate interior angles. Okay, again, in a parallelogram, opposite sides are parallel, meaning if you put transversal, which is the purple line, you will have alternate interior angles. So look at that, the 5x, look at the 5x, the 40 and the 70 are now interior angles of a triangle. So we add all of them to add up to 180 degrees. So let me just erase that first. Oh, sorry. Okay, so 5x plus 40 degrees plus 70 degrees equals 180 degrees. Adding this one, that gives us 110. So subtracting 110 here, subtracting 110 here, so we have 5x equals 70 degrees. Divide by 5, divide by 5, so x is simply, so our reason here is this is angle sum of a triangle. That is very necessary to state your reason. Why? Because in mathematics, your answer may be correct, but the reasoning is wrong. It's okay that the reasoning is correct and the answer is wrong because there might be some careless mistakes. But being correct, but the reasoning is wrong, that's maybe accidental. Okay, so x is 1 6, that is 14. X is 14. So next, we have alternative solution for the 5x. It's the same equation, but the reasoning is different. Look at this. Remember this idea here a while ago. What we did is we added 110x, 110 and 7x. Because they are supplementary, because they are consecutive interior angles. It is actually the same with these angles. Look at these angles. This 5x and this entire 70 and 40. So notice that they are consecutive interior angles. So let's redraw that. Let's redraw that as a parallel parallel lines with transversal. So there is that's the parallel side of the parallelogram. Then there is a transversal, and that's it. That's the purple. Then we have, look at this, that's 5x there. Then there is another transversal cutting this somehow into 70 and 40. So as you can see, this side, this one are actually applications of, these are actually parallels and transversal. So how do we know that they are parallel? It's a property of a parallelogram. Okay, it's a property of a parallelogram that the opposite sides are equal. So meaning, yeah. So from there, we can now say 5x degrees plus 70 degrees plus 40 degrees. So look at this. The equation is the same, but our reasoning here is angle sum of a triangle, because we tend to use the 40 here to state that 40 there by alternate interior angles. But here we use this by this concept. That's consecutive interior angles. So this one is consecutive interior angles are supplementary. Okay, and since they are the same equation, it will lead us to x equals 14. So next is we have the 6y. So what given angles are related to 6y? Okay, look at this. I want you to focus on this. 120 is actually equals to 6y. So from there we say 6y is actually equals to 120 degrees. Why is that? Why is that? So let's take a look. Notice this. They are also parallel. They are also parallel. This becomes a transversal. Okay. So from there, the 6y and 120 are actually corresponding angles. Okay, are actually corresponding angles. So let's redraw that one. So we have that one. Okay, this is being 120 and this being 6y. So they are actually corresponding angles. So let's go back to the concept of corresponding angles that it will be sure. Here, they are corresponding angles, the A and the E. So it's like the A and the E. Okay. So again, it's just spotting that, using those small concepts and trying to spot this small concept in a bigger problem. So we have our reason for that is corresponding angles are equal. Okay, so yeah, we can solve first. That is just 20. So that's it. Okay, those are the some problems involving angles in a rectangle and angles in a parallelogram. So again, in mathematics, you combine small concepts to solve a bigger some kind of a problem, and a complicated problem. So as you can see, we solved some complicated problems about angles in a rectangle and in a parallelogram, but they are not really that complicated because we know the tools. Okay, we know the tools. What are those tools? Are already those concepts that we discussed and learned before. So it is very important, the mastery of those before lessons, okay, the prerequisite lessons, because you use them as a tool to learn the other lessons. Okay, it is why it is important that you have to really join the discussion, ask questions, and somehow master the concept, familiarize the concept, then apply it in the problem. So that's your task there.